Hi guys, welcome. For those of you that missed today's small group session because you had NWEA testing to work on, thank you for taking the time to watch this video so that way you can stay on track. We are going to cover 1.08 and 1.10, scientific notation, and then adding and subtracting within scientific notation. So one thing that you guys need to make sure is that you've completed both of these modules on OMHS. So OMHS is that main page where you have all of your courses. So if you haven't completed both 108 and 110, please pause this video, complete them, and then come back and watch, because that is always the order we need to do things in. So our specific learning targets for today are that you will be able to convert numbers between standard form and scientific notation. And then once you've learned how to do that, that you can use operations, so specifically adding and subtracting, to be able to solve problems with numbers written in scientific notation. All right. It's not going to the next slide. There we go. So with scientific notation, we're going to get to what that looks like in a moment, but one of the reasons we use it is for numbers that are really, really large. So if we look at all of these different examples here, we have the volume of the Great Pyramid, the weight of a blue whale, and then, oh my goodness, the mass of the sun. I don't even know how to pronounce that number. There are way too many zeros. I don't even want to think about having to add and subtract with that. I'm going to get my zeros all mixed up. It's going to be a lot of writing. What if I miss one? So when you have numbers like these that are really, really large, they're difficult to pronounce. They're difficult to work with. So that's why we have scientific notation. Also, the reverse of that, if we have numbers that are really, really tiny. So the diameter for a grain of sand, that number is not too bad. But then if we look at the mass of a dust particle or the mass of an electron, once again, we have a really, really small number, but I still have tons of zeros. So that's really difficult to pronounce and really difficult to work with. So that's why we have scientific notation. So we can rewrite all of these numbers in standard form into scientific notation. It makes it easier to read, easier to say, easier to work with. All right, so this right here is what scientific notation is. Scientific notation expresses numbers as the product of a coefficient and 10 raised to some power. So our coefficient, all right, so this a, since I'm representing this with a variable, that means that's going to end up being replaced with a number. That's going to be changing. So we're going to have some number that is greater than or equal to 1 and less than 10. So another way of saying that is we need to rewrite the numbers so that way my coefficient is between 1 and 9. And then it's multiplied by 10 to some power. Our base is always going to be 10. Okay, so that's kind of one thing that helps you know it's scientific notation is if you see it written like this, I have a number times 10 to an exponent. That tells me it's scientific notation. The reason that we always have a base of 10 is because that's our number system. We work in sets of 10. So if we think about our place values, tens, hundreds, thousands, those are all multiples, those are all groups of 10. So that's why we have that. And then our exponent can either be a positive or a negative integer. And we'll get into how you determine the exponent in just a moment. So anything in this format is scientific notation. All right, so let's get to our first learning target. So we want to express 870,000 in scientific notation. So this matches our first learning target of converting a number in standard form. So it's standard, it's what you're used to seeing, into scientific notation. So our first step is we want to write the number down without a comma. The reason for this is we don't want to accidentally think the comma is a decimal point. And so it just makes it a little bit easier. It makes it less likely for us to make an error when we write it this way. All right, next, if we think back to that picture we saw, we know that we need to rewrite our number so that way it falls between 1 and 9. Obviously, this doesn't fall between 1 and 9, but if I move my decimal point and put it right here, I have 8. Does 8 fall between 1 and 9? Yeah. So that means this is acceptable for scientific notation format by me moving my decimal point here. So our third step is to physically move that decimal point and to count our places. So if you guys recall, all numbers, if you don't see a decimal point, all numbers have an invisible decimal point at the end. It's just if nothing is to the right of it, we don't write it. So an example of that we could think of like money, because you can say that you have $1 by just saying a 1, or you can say you have $1 by doing 1.00 cents. They both mean the same thing. So in order to get this so that way my coefficient falls between 1 and 9, we have to move our decimal point all the way up to here, which is 5 times. That movement is what becomes your exponent. So to officially rewrite it into scientific notation, we're going to drop all of our zeros, and we have it rewritten as 8 7/10 times 10 to the 5th power, because I moved the decimal point 5 times. Another fun little fact is this 5 is a positive number. So by noticing that it's a positive number, that tells me 2 things. That tells me that I started off with a really, really large number and had to move my decimal point to the left. So the exponent, since it's positive, tells me the direction I moved the exponent, the direction I moved the decimal, and that it was a really, really large number to begin with, and how many places I moved that decimal. All right, let's do a little practice. Now, obviously, we're not on Blackboard, so you can't really use the polling tool here. So either answer quickly in your head or pause the video and then hit play once you come up with the answer, because we always want to try these, because by participating, that's how we learn. That is how we make sure that it clicks. Even if you get it wrong, we learn from our mistakes. So in scientific notation, the exponent's value is at A, how many zeros were in the number, B, how many times the decimal was moved, or C, totally random, no significance. All right, if you don't have the answer yet, hit pause because I'm going to reveal it. It is B. The exponent's value tells you how many times you had to move that decimal point in order to rewrite it in proper scientific notation form. All right, question number 2. In scientific notation, if the exponent is positive, does that mean A, you moved the decimal to the right, so it was a very, very small number? B, you moved the decimal to the left, and so it started off as a really large number? Or C again, random, no significance. All right, hopefully you guys said B. So when you notice the exponent is positive, that means it started off as a really, really large number. So these are a couple key facts that if you guys don't already have this in your math notebook from completing the OMHS lessons, this would be a good thing to go back and revise and add this to your notes, what the exponent's value means and what it means if it's a positive value. All right, let's try another one. This time, let's express 0 and 43 millionths in scientific notation. So now we're going to take a really, really small number, in value, of course, not in length, and rewrite it into scientific notation. So this time, I just need to write the number down, because when we have numbers written in decimal format like this, we don't have commas. So there's no comma to take out. We just need to write it down. just like before, we need to figure out where that decimal point needs to be moved. Now this one is visually a little different, but once again, we want the number, and we're gonna kind of block out the zeros. We want the number to the right of get my directions mixed up, to the left, so right in front of the decimal. We need that value to fall between 1 and 9. And so if I put it way back here where my cursor is, that'd be 43. That doesn't fall between 1 and 9. So that means it has to go here between the 4 and the 3. So then the value right in front of the decimal is a 4. And that falls between 1 and 9. So we're good. All right, just like before, now that I've chosen its proper location, its new location, I need to actually move the decimal point and count how many times I move it. So from our starting point to our new location, it's moved 1, 2, 3 times. Now, here, when I move it to the right, instead of my exponent being a positive 3, it will be represented as a negative 3. So that is a big difference. So this part is still the same. I still represent it as 4 3/10 times 10. Scientific notation, you always have a base of 10. 3 still tells you the movement, but the negative it tells you it's the direction. It tells you you had to move backwards, you had to move to the right, and that it is representing a really, really tiny number in value. A couple more practice problems. So in scientific notation, if the exponent is negative, A, you moved the decimal point to the right, so it represented a really small number. B, you moved it to the left, so it represented something that was a large number. Or C is random, has no significance. I'm going to reveal the answer, so if you guys haven't picked it yet, hit pause. All right, the answer is A. So a negative exponent helps you know that, okay, that came from a small number. That was the direction I had to move the decimal. All right, let's try one out. So which one of the following choices is the correct way to write 48,900 in scientific notation? So this is one, because it's always good to have examples in your notebook, because that's, for me personally, the best way to get help is to look at physical examples. So I would write this down, work it out, and then if you get it right, awesome. If you get it wrong, that's okay. You can either cross it out if you use pen or use an eraser to fix those errors, because that's also how we learn, is by correcting mistakes. All right, let's go over this. So I know you guys probably haven't finished it yet, so please pause and return once you've completed it. The correct answer, well, before we go over the correct answer, let's look at our answer choices and see if there's any that I can automatically eliminate as being correct. What stands out to me is B right here, because my value in front of the decimal point is 48. Does 48 fall between 1 and 9? No. So that means B is definitely not the right answer. But I have to look at A. Yeah, 4. That's between 1 and 9. Looks good. And then just a 4 again in C. That looks good. So my answer choices have been narrowed down to A and C. And the correct answer in this case, oh, why is it not letting me? There we go, is C. So let's go over how we arrived at this answer. If we look at our number here, I first want to rewrite it without the comma, because if you guys got A, that could have been, oops, sloppy handwriting, that could have been one of the things that tripped you up. All right. The other thing is we need to remember that when we don't see any decimal points, that means there really is a decimal point at the very end of the number. Just if nothing follows it, we don't need to write it because there's nothing that follows it. So in order to move it right here where we want to go, we go 1, 2, 3, 4 times. And since I moved it to the left and it started off as a really large number, it is a positive 4. Okay. All right, let's check out our next part of this. Oh, let me clear this. All right, let's review adding and subtracting in scientific notation. Now, this is a part that, for those of you that were part of the small groups, if you're watching this, we didn't get to today. And so I had expressed that you guys should return and come to my office hours tomorrow at 4. You still can, or maybe by watching this, this will get you some assistance a little bit sooner than that. So whenever we need to add or subtract in scientific notation, the first thing that we must do is verify that both of ours are raised to the same power. This is important. It's kind of like terms. We need them to be alike. So both of these numbers are raised to the 4th power. So when that happens, I get super excited because I'm like, oh yes, that means they are ready to go. I don't have to change anything. I just have to add. So that's exactly what we're going to do, just add. So this takes us back, step 2, we just need to add or subtract our coefficient. So 3 and 42/100ths plus 4 and 1/10. And we just follow the rules of adding decimals that we learned in elementary school. Now, if it's been a while since you guys have done this, remember that when we are adding or subtracting with decimals, we always have to line up our decimal points. So when they're lined up, we may need to add some 0 placeholders in so that way we can actually do that addition. So go ahead and add. When we do so, our sum is 7 and 52/100ths. And then we just need to write our total in scientific notation. So we added our 2 coefficients, so our 2 numbers written as decimals, and we just rewrite it in scientific notation. Our power, because it started the same, stays the same. So it's very much like combining like terms. They have to be alike. You just combine that coefficient and we're good to go. Now, you may be saying, Mrs. Elstock, what if they don't have the same power? What do I do then? I got you. I got you. All right, that's what we're going to go over here. So if you notice that they do not have the same power, you need to change one of them so they do have the same power. Now, how do we do that? Well, we change it by moving the decimal, because remember, your exponent tells you how many times you had to move the decimal. So we're going to take one of these out of proper scientific form so that way they can be added. So one of them is temporarily not going to have a coefficient that falls between 1 and 9, but that's okay because that's what I need to do to perform the operation. And then we'll just make sure our final answer is good to go. So it really doesn't matter which one you use. I personally am going to go this way because I know that if I move my decimal point to the left, that's those positive numbers. So it's going to add 1 because I'm moving it 1 more time. So I'm adding. If you wanted to go the other way and you're taking 1 away, so if we wanted to change this one, I could move it 1 to the right, take 1 away, which means your exponent would go down to a 4. So it's really no right or wrong way. Just make sure you recognize whether you're moving it to the left and you're adding a decimal point like we did here, or if you go reverse, you would have to move to the right and take 1 away. But now that they have the exact same power, it becomes like that other example. So that's the only extra step. So if you notice that they're not raised to the same power, you need to convert 1 so their powers match, then you're good to go. So let's refresh our memories on subtracting numbers written in decimal form. Remember that when we subtract numbers in decimal form, it's similar to adding, where we have to line those up, but we always need to make sure the number with the larger value is on top. So obviously this has less digits, only 2 digits, a 4 and a 1. This has 3 digits, a 0, a 7, and a 2. But with subtracting, the larger value needs to go on top. So 4 has a larger value than 72 hundredths. So this must be placed first in order for us to properly subtract. And once again, that's really the only extra tweak. Everything else is the same. So remember all those borrowing techniques that you need to borrow when you have to subtract. And you will get 3 38 hundredths. Now I just need to rewrite it in scientific notation. And clearly I have a big old typo there because that doesn't match, does it? Sorry about that, guys. All right, so if you guys watched this part of the video and you realized that I made a typo, send me an email and you can get a bonus point. So if you guys watched the video, you found it helpful, you realized I made an error, send me an email saying, Mrs. Ailstock, I caught your error. You'll get a bonus point. All right. So just a few little reminders that these things, these OMHS and IXL assignments are all from last week, so they should already be completed. And then this contains this week's assignments. So you should have already gotten some scientific notation and 1.010 done. You have a couple more in scientific notation to do before Friday, and then some IXL assignments. Also, a key little area here is you've heard about this, I'm sure, in your ELA classes, but you need to spend at least 15 more minutes for the math portion working. So that means since they merge ELA and math questions in the diagnostic arena, you can look at it as a total of 30 minutes working in that per week. So like 15 minutes count towards math, 15 towards reading since they're merged. If you guys have any questions on any of this, of course, you can send me an email, or tomorrow, Thursday at 4 o'clock, hop into my office hours and I can help you with OMHS, IXL, or math itself. All right. Bye, guys. I hope that you had a good day, and I look forward to seeing you either tomorrow or Friday.